Welcome to the 3.3 Part 2 notes. Today we're going to find the derivatives of inverse functions. Say that f of x and g of x are inverse functions. Then f composed with g of x is x, and g composed with f of x is also x. In other words, if I take any number x and throw it through the function called f, the output is called f composed with x. Then if I take that f of x and throw it through another function called g will undo whatever f did, and so it's going to spit back out just x. Okay, so they undo each other. And the same thing happens if you were to reverse the order and go backwards. If I put x into g, I would get g of x out. And if I put g of x into f, I would get x out. Okay, so these functions undo each other. Now, let's take the derivative of either composition. Okay, so we know that f of x composed with g of x has to equal something, okay? And it equals x, right? So we know that when I put x into g and then put g into f, then I get the original x back out. And let's take the derivative of both sides of this expression and see what happens. So on the left-hand side, to take the derivative of f of g of x, we have to use the chain rule. And so the chain rule states that I would have f prime of g of x multiplied by whatever g prime of x is. And so that's the chain rule multiplied by the derivative of the inside, but take the derivative of the outside first. So f prime of g of x times g prime of x. What's the derivative of x with respect to x? Well, that's just going to be 1. So then if I solve for g prime of x is equal to 1 divided by f prime of g of x. Now remember that g is the inverse function of f, right? The notation we use is f with this little -1 in the top right. Now it's important to realize again that -1 is not an exponent here. It's not the reciprocal of f. It's literally what undoes f, the inverse function. So if I change the notation then of this whole expression to have f inverses instead of g's, you'll notice that we get our inverse derivative formula that we found yesterday. So that's kind of where this all comes from. Now let's do a couple of examples. I know we did some yesterday, but I want to make sure that we get extra practice on this because this is a challenging topic. Let's find the derivative of the inverse of f of x equals the square root of x minus 4 at x equals 2. Okay, and so if I'm going to use this formula, if I want to find the derivative of the inverse of f at x equals 2, then the formula would be 1 over the derivative of f at the inverse value of 2. Now when I say inverse value, this expression f inverse of 2, it's saying that the point 2 comma something is on the graph of f inverse. Right? When I put 2 into f inverse, I should get a y value out. Now on the original function f, the inverse point would be on the point, the inverse point would be on the graph of f. So in other words, the point box comma 2 would be on the original function f. Since I have the original function rule for f of x, I can set that function rule equal to 2 and find what the value would be to go in the box, because then I know that's going to tell me what f inverse of 2 is. In other words, you're asking what value of x when put into f will get me 2, so that way when I put 2 into f inverse, I get that value back out. And so if I square both sides of this equation, I get 4 equals x minus 4. And it's clear to see that the x value would be 8. So 8 is going to be what goes inside of this box, and 8 therefore would be the output of f inverse when you put in 2. So then I'm going to go and continue to work on this pink expression, f inverse prime of 2 would equal 1 over f prime of 8, because 8 is what f inverse of 2 is. Now let's take the derivative of f of x. I'll do that right up here so I can save some room. F prime of x would be 1/2 x minus 4 raised to the -1/2 times the derivative of x minus 4, which is just 1. So in other words, I have 1 over 2 times the square root of x minus 4. Now if I put 8 into that expression for x, I get 1 over 2 times the square root of 8 minus 4. So they get 1 over 2 times the square root of 4, which is just 2, So I get 1 over 1/4 or just 4. Now what have I just found? Why do I care about this? Well, let me just graph the original function f of x over here on this graph. And I'm going to use red for f of x. Now f of x is the square root of x minus 4, so that means that I start at the value 4, 0, and I graph the square root function. It should look something like this. Okay, so there's the graph of f of x. Alright, and f of x is equal to the square root of x minus 4. So what I'm asking for when I find the derivative of the inverse function is I'm finding the slope of the inverse function when x equals 2. Okay, now it should be weird to you that 2 isn't even on the domain of the function f, but it is in the domain of the function f inverse. That's because the domain of f inverse would be the range of f. That is, all of the y values that f touches would be the inputs of the inverse function. Now in this case, we can find the inverse of f of x pretty easily by using the method that we talked about in the last video, and that is by switching x and y around and solving for y. So when I do that, I can get x squared equals y plus or minus 4. So the inverse function would be y equals x squared plus 4. Now let's graph that. X squared plus 4. Looks like this. Now hopefully you can see that if I were to graph the line y equals x, it's just a reflection of the red graph over this black line that I'm drawing. Okay, so I've just taken the red graph and like a mirror flipped it over to be here. Now notice that since x is the square root of y minus 4, x has to be greater than 0, because there's no way you can get a negative answer when you're taking the square root of some number. So that's why my domain is restricted on the green function so that x is greater than 0. In the same way, the domain is restricted on the original function f, that x has to be greater than 4 for the f of x function, because I can't put a negative in the radicand of a square root. And so going back to what this problem is asking for, we want the slope of the derivative, we want the slope of the inverse of f when x equals 2. So according to the graph, if I find x equals 2 and go up to the inverse function, I'm finding the slope of the tangent line right at this point here. Alright, and so the slope should be roughly 4, which is what I found on my algebra work, and that should make sense, okay? One interesting thing here is that the inverse point, this is at 2, 8. The inverse point that should be on f of x should be these two numbers switched around. So we should have the point 8, 2, which we do. Well, what's the slope of the graph at 8, 2 on the original function f of x? The slope here of the blue line is 4. Well, if I take the derivative of f, again, I get 1 over 2 times the square root of x minus 4. That is f prime of x. If I put in 8, I get 1/4. So the slope of the graph of the original function when x equals 8 would be 1/4. Do you see the relationship between the slopes? The relationship between the slope of an original function with its inverse at the inverse points, that is when you switch x and y around, is that the slopes are reciprocals. That is, the slope of the original function was 1/4 at 8, 2, and if I take the inverse point, 2, 8, the slope should be 4, or the reciprocal of that. Find the derivative of the inverse of x cubed plus 3x minus 1 when x equals 5. Alright, using my expression for the derivative of the inverse, f inverse prime of negative 5 would equal 1 over f prime of f inverse of 5. Now remember, if I have a point negative 5 something on the original graph of f of x, then on the inverse of f, that's really bad. Let me fix that. On the inverse of f, the point should be box negative 5. So in order to find what the f inverse of 5 is in this expression, I need to take the original function and set it equal to negative 5. I think I had that backwards. If I want to find f inverse of 5, negative 5, that's going to equal something. And on the original function, it should be box negative 5. Sorry about that. So I need to know what the y value is when I put negative 5 in to the inverse function. And so to do that, I set the original function equal to negative 5. So then I add 1 to both sides. Or actually, rather, it's a cubic, so I want to move the negative 5 over. So I'm going to have, looks like positive 4. All right, now you might be tempted to try to factor this because it looks like a quadratic, but in fact it's a cubic. And so you could use your calculator to solve this, or you could use guessing and checking. And so in this case, I happen to know that the value would be x equals negative 1, because I'd get negative 1 minus 3 plus 4 would be 0. So the value for f inverse of negative 5 is negative 1. So I need to calculate 1 over f prime of negative 1. Okay. Now from the graph of this, you can see on the right, if I put in negative 1 in for x on the original function f of x, which I have graphed here, this is f of x equals x cubed plus 3x minus 1. The point at negative 1, negative 5, that's the x value when the graph is equal to negative 5. It's negative 1, so that's why I'm putting it in. All right? Now the derivative of f would be 3x squared plus 3. So I need to put a negative 1 into that expression for x. And so then I get 1 over 3 plus 3, which is 6. Okay, so the slope at the inverse point would be 1/6. Then what is the slope here when x equals negative 1 on f of x? What is f prime of negative 1? Well, it should be the reciprocal of this fraction. It should be positive 6, which hopefully you can see it is. If I draw a slope of positive 6 and try to hit a tangent line there, that makes sense that it should be about 6 when x equals negative 1 in the original function. Now, this function is strictly monotonic, which means it's always increasing, and that means I can find the inverse relatively easy if I switch this around. This is y equals x cubed plus 3x minus 1. And so if I were to try to graph this, or find the inverse function, it'd be x equals y cubed plus 3y minus 1. So maybe I can't do it very easily, but the inverse will exist on this. And so we'll save that for a later time. Here's another example. Let g and h be inverse functions. So it says that they're inverses, so that means that g composed with h would just give me the original value x. Find h prime of 1. Well, since h is the inverse of g, then to find h prime of 1, that's equal to g inverse prime of 1. So that expression, of course, is 1 over g prime of h of 1. So to answer this part, the inside, h of 1, that's going to be whenever g is equal to 1, right? Because on the function h, if I want to put 1 in to h, on the original function g, the point would have to be box comma 1. So I want to know, when does g equal 1? G equals 1 when x is 3. So then I will put 1 over g prime of 3. Well, g prime of 3 is negative 2, so I have negative 1/2 as my answer here. Let's let h, and this should be the next one, so it should be 3.311. Let h be equal to 7 minus x minus 2x to the 5th. If f is the inverse of h, find f prime of 10. Well, f prime of 10 would equal 1 over h prime of f of 10. Now, like I mentioned, since f is the inverse of h, when I put 10 into f, I'm going to get something. And then on the original function h, it would have been when you put in something, you get 10. So I'm going to take this original expression and set it equal to 10. Now when you do this, it's going to be kind of hard to solve a cubic here, all right? And so this should be a negative 3 minus x minus 2x to the, did I say cubic? I meant quintic to the 5th power. You can use your calculator to solve this, okay? So if you need to, you can use your calculator. I'm just going to go ahead and do that quickly to get the value. All right, and so when I plug that into my calculator and I get the value, I get negative 1, I think. X equals negative 1. All right, and that should work. So if I put that in there, it's negative 3 plus 1 minus a negative 2 times negative 1 is positive 2. So yep, that's going to be 0. So x equals negative 1. So inside of this box, it's negative 1. So I need 1 over h prime of negative 1. So to find h prime, I can just take the derivative right up here. H prime of x is equal to negative 1 minus 10x to the 4th. So put in negative 1 into that expression, and I'm going to get negative 11. And that's my slope. Okay. Here's another table problem. Let f and g exist such that f of g of x is equal to x. So we know that they're inverse functions because they undo each other, and you just have the input as your answer. Find g prime of negative 2. Well, g prime of negative 2 would be 1 over f prime of g of 2. And again, what I'm looking for here is if this is the g function, when I put in 2, it's going to equal something else. To find out what that something else is, I want to know when is the original function f equal to 2. Okay, so of course that happens. F is equal to 2 when x is equal to negative 2, right? When x equals negative 2, f of x equals 2. So inside of that box, it'd be negative 2. So then I get 1 over f prime of negative 2. F prime of negative 2 would be 1, so it's just 1. Here's another example. Let g of x equals this polynomial expression. It looks like a cubic trinomial. Let g inverse be h of x. Find h prime of 7/4. So again, if I want h prime of 7 over 4, since h and g are inverse functions, it'd be 1 over g prime of h of 7/4. And as always, if the original function, if h has the 7/4 as the input, it's going to equal something. And on the original function, that something would be the inputs to equal 7/4. Okay? So when I look at this, I need to set the original function g equal to 7 over 4. So 7 over 4 equals 1 over 8, x to the 3rd, plus 1/2 x minus 1/4. Again, you're going to want to set this whole expression equal to 0 and then use your calculator to help you out here. You could try guessing and checking, but it's going to be pretty tough for you. This is going to be negative 2. And so I will use my calculator now to find that value. Okay, so just give me a second here. I can't pause the video from recording, but I'll go ahead and just type that in. Positive 1/8 x cubed plus 0.5 x minus 2, and I want to find out when that equals 0, so I'll graph it. According to my graphing calculator, that happens when I think x equals 3, but I better check using the 0 function in the calculator. It actually ends up being something different. I hope I graphed that right. Alrighty, so yeah, it should be like 3 point... of course, I exited out of the screen now. 3.189 is the input. So that's going to make it 0. So 3.189 is what I need to put into the derivative of this expression. So I'll go ahead and do that. 1 over, and then the derivative of this would be 3/8 x to the 2nd plus 1/2. So it would be 3/8 times that number squared plus 1/2, provided I didn't make any mistakes. 0.189, 3.189 squared times 3/8 plus 1/2, 1 over 4.314, and that ends up being roughly 0.232. All right, thanks for watching. I know this is a tricky subject, and you could tell obviously that I get confused sometimes also, but thank you for watching.